regression, regression. So now again, like if you are predicting weight of the child or FEV1, BMI, duration of hospital stay, what regression you will use? Linear or logistic? Please write in the chat box. Okay. No, Anju, we will use linear because linear, Dr. Chinta, we will use linear. Why? Yes, anyone? Shirley, you can answer this. Why will we use linear for such variable? Outcome is continuous. Okay. Anju is writing outcome is continuous. So we will use linear because BMI will be in continuous. Duration of stay is a continuous, all continuous. Now, if the variables are like this, post-op complications, immunization status, varicose bleed, present absent, fatty liver disease, present absent, dementia, present absent, depression, present absent, complete recovery occurred, not occurred. If the outcome variable is like this, then logistic. Which type of logistic? Because there are many types of logistic regression. Yes, binomial logistic. True. So binomial logistic, in this case, there is something known as the response variable, which is also known as the outcome variable, or which is also known as the dependent variable. These three are synonym: dependent variable, outcome variable, response variable. Then there's something known as the independent variable. Another name of these independent variable is predictor variable, and another name of this predictor variable is explanatory variable. So the same example, admitted newborn will get sepsis, whether a family will fully immunize the child, patient will comply to treatment, whether a student will pass, whether a village will adopt a government policy, or whether a person will commit suicide. All these are variables which are binomial. But there is a problem because there are many predictor variables. Like Vikram was asking, what is a full model? So whenever you will take this, you will see that there will be many variables in your data set. So which variables to take as a model? How to decide for that? So first, there are two criteria for this. First, you need to choose few predictor variable which you think it can predict the outcome of interest, maybe by reviewing the literature, maybe as a clinician, or you may ask the clinician, like according to them, which are the variable which is of importance. That is your clinical significance. And then you can see the statistical significance. So you can do a like 2x2 analysis, one variable with one, and if the value of p-value is, here the cutoff we don't take 0.05, but we are a little lenient. So we take the cutoff of 0.2. So then, suppose you have sorted out 10 probable predictor variable based upon your best judgment. And now you run the statistical analysis to find the most significant variable out of 10. So you do 1-to-1 analysis. One variable and the outcome, variable 2 and the outcome, variable 3 and the outcome. And we select those variables which have got the p-value of 0.2. So this predictor variable is again a categorical variable. So why should we be lenient in selecting the significant predictor variable? What is the reason? We should be lenient because many times you will see that there is something which is the unadjusted. So when you do this one by one analysis, that odds ratio which you get, that is the unadjusted odds. Remember, recall day 2 session. So those odds ratio which you were calculating, those are the unadjusted odds. But when you take many so what do we mean by unadjusted? Yes. Okay, so unadjusted is, since I'm not getting any response, unadjusted is you are only taking that particular factor. You are not taking, remember, recall that event of taxi fare and your kilometer travel. So if you are doing a odds ratio of, maybe both are a categorical variable in 2 by 2 table. And if you take only one variable, yes, then it is known as the unadjusted odds ratio. But many a times you will find that in unadjusted, only 1-to-1 analysis, that variable is not significant, not that much significant, but in adjusted, it became significant. Okay, that we'll see. Like in this case, you can see here, this is again a one table where the person, the author is, like the dependent variable he has taken as a postpartum depression using logistic regression. So this is the crude odds. So unadjusted odds is also known as the crude odds, and adjusted odds is the where you have got many variables. So you can see here that this, it is 0.38, which is very less, which has become 7.48 here in the adjusted. I am not focusing on whether it is significant or not, but the value of odds ratio that has increased in case. So this is important, that you should take a cutoff of those variable where the p-value is up till 0.2. So now there is something known as the sample size. So if you have got a 40 study subjects, then how much variable you should take? So basically there is a rule that you should not, at least you should have 10 individual or 10 sample per variable. So if you plan to take 5 variable in your model, you should have the 10 outcome, not as a 10 sample, also 10 outcome per variable. So your sample size, if your sample size is very good, then only you can take many variable. Otherwise, there is a data sparsity bias which comes in. Like in each cell, they will have less. So it is something like if you make too many chi-square, like if you make 7 by 5 chi-square table, what happens? In each cell, there are very less numbers. So that's why we always say that you should club those tables. Similarly here, if you take many variables, then there will be bias. So the criteria is at least 10 outcomes per variable. That should be there. So now what to do? So finally, we select some predictor variable for logistic regression. And we want to predict at the time of admission. If we want to predict at the time of admission whether the person will need ICU or will not need ICU. So the basic difference between, again, one summary point, linear regression, we do a continuous regression, continuous prediction, and in logistic, we predict categorical. So logistic regression, in this case, every probability of a dependent variable can be converted into log odds by finding the log odds ratio. And that log odds algorithm, also known as the logit function, uses a certain formula to make this conversion. So this is a binomial logistic regression, predicts the probability of a dependent variable, and independent variable can be a continuous, or it can be a categorical. So you know that linear versus logistic regression. So what will be the answer in this case? If you want to predict at the time of admission, which patient of COVID will need the ICU? So what will be the option? It will be the logistic regression. Similarly, how to measure odds ratio in logistic regression? So there is an unadjusted odds when you have got only one independent or predictor variable, and you have got an adjusted odds. So we have talked regarding this adjusted and unadjusted. So there are some underlying assumptions. What are those assumptions? First is there should be one dependent variable that should be this dichotomous, and that category should be two, only the two outcome. And the independent variable, they can be either on a continuous scale or on a nominal scale, and there should be independence of observation. All variables should follow this, and minimum of 15 cases per independent variable. You may take 10 to 20, 15 is also okay. So there is a range. And now, so that's what I was saying. Hriday, what should be the minimum sample size? It depends. That minimum sample size depends on how many independent variable you want to put in the as a predictor variable. If you want to take only two variable, then 30 outcome should be there. Okay, if you want to take three variable, then sorry, like it is range from 10 to 20. So you can take either 10, 15 or 20. So if you take 10, then for three variable, you can take 30. If you take four variable, then you can take 40. Is it okay, Dr. Hriday? And remember that 40 is not the total sample. That 40 is the outcome. Because this binomial, you will also have something happened and something not happened. Like diabetic foot happened, diabetic foot not happened. So those 10 cases means those are the outcome. Okay. So if it is a very rare outcome, you will have to take many samples. Total sample size will be much more. This 10 criteria, whatever we are saying, that is not total. That is what? Don't get confused. Because initially, we got this, in one of the session, participants thought that it is the 10 overall sample size. But no, it is not the 10 overall, it is the 10 outcome. So now, it can be testing using model fit and pseudo R-square statistics. And their assumption, this pseudo R, if the model fit is significant. So Vikram, one variable presence must be minimum 10 times in a sheet. This pseudo R-square is same as the adjusted R-square. So adjusted, in this case, you can say adjusted R-square. Yes. I don't know why it is called as pseudo, but it is adjusted. So if the model fit value is significant, if it is less than 0.01, 0.05, then we can say that the linearity assumption is met. In the SPSS, we have got something like box Tidwell procedure by which we check for linearity, but we are not going into that detail here. And here you can say that if the value of model fit is less than 0.05, then the assumption of linearity is met. Again, the data should not show the multicollinearity. And in this case, there is only one multicollinearity statistics in JAMOV, that is the correlation coefficient. So if and there is something known as the VIF and tolerance values also. So if there are multicollinearity, then there is a problem in interpretation. So the value of this correlation coefficient should be less than 0.8, and then there should not be significant number of outliers or highly influential point, which we test by the case-wise diagnostic, which I think we don't get that in the JAMOVI, that is there in the SPSS. So this binomial logistic estimates the probability of an event occurring. This we have discussed, the 0.5. So now coming to the exercise. So any question up till this point? Then we'll go to the demo. So no question?
Ma'am, just that part.
Vikram, yes?
Ma'am, like if we have some sheet and we have like yes, no variable.
Yes.
So, for example, that no must be minimum available 10 times in that sheet.
No available or yes available?
Or yes, anything. Minimum 10 times it must be there in sheet. Then we must put that for this regression purpose.
Actually, initially also we thought of the same thing, but then we concluded after reading one or two articles that it should be 10 outcome. That means if you are taking no as an outcome, then your criteria is okay. If you are taking yes as an outcome, then obviously that yes should be there 10 times. Okay. But still, if there is some confusion, we can clarify it. If you are like that, that's what we concluded after one of the sessions. That confusion arose that time also. And then there was a reference, I guess, of some article. We checked that and then we have found out that. But still, Vikram, if you are saying, yes, thank you. It's just URI, maybe the season is changing, that's why. Thank you, Akhila. Dr. Prashanta is writing unadjusted ORS by frequency table. That's why at the time of that odds ratio calculation, you can have unadjusted odds here in logistic also, because there you cannot, if you have got a continuous variable in 2x2 table, you will not get the odds ratio. Did you get, Prashant? In this thing 2x2 table, you can only get unadjusted odds using a categorical variable. So that's why you can use the logistic option also. And remember, in the odds ratio, we told you that in this case, it is easy for interpretation because it gives the reference value also, which was not there in the 2x2 odds ratio calculation. Here you will see, and you can change also. Although in the breakout room, you must have learned that you can change that, but again, that is not visible in the output. So maybe let me open the sheet and question, because I have not opened that. Initially, I planned to tell the McNeighbor and correlation. So this is the, I'll read the question. So I have to use an appropriate regression approach for predicting death using age, gender, race, cardiovascular disease, MI order, MI type, PMI category, smoking status, and baseline hemoglobin value as predictive variables. So there are many variables. You will see 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'll see initially, like maybe clinically, we think that these are the variable, and we'll see how to do that. So how to do that first? So what is my first step? I'll check for the assumption. So assumption is tested. You have those descriptives with you, where you have those outliers with the continuous variable, like maybe age, and the hemoglobin. So you should have be checking the normality of the continuous variable. And you have, I guess, and I assume that since you have done the descriptives of all variables, so you have got that data. So now I assume that maybe there is no outlier and they are normally distributed. So next will be, I have to, so what I'll do, I'll go to this Jamovi and let me write down all the like age, gender, race, 2 MI, BMI, cat, smoking, and baseline. So this is the Jamovi sheet. In the option, you click this regression. And till now, what we have learned this exploration, where we have seen the descriptive. Then on this we have learned regarding the independent sample t-test, paired sample t-test, and one sample t-test. Yes, Anju, we see the distribution of only continuous variable. Dr. Soma, this data is there in the data file. You will get this data. Dr. Shamshad, this data is there with... yes, you have access to this data. Maybe this is different from what you people are doing till now. This is a different data set, but you have this data set. Then we learned regarding this one-way ANOVA and Kruskal-Wallis, the repeated measure ANOVA. Then we learned regarding this frequency, where you learned regarding the chi-square test of association, chi-square test of two proportion. And then today we'll see this McNemer test, which we have not touched yet. And there is something known as the regression. So this regression, you can see, this also we will learn correlation matrix. And this is the option of binomial correlation. Sorry, binomial logistic regression. So if I click that, what is my first task? I have to see whether what is the unadjusted odds and their p-value. Because if the cutoff is more than, if the p-value is less than 0.2, then only I can take the value. So what I'll do, what is the dependent variable? So this F stat is the death or the alive at the end. So this is the one. And the variable, I'll take age first. And in this case, you can see there are two boxes. The continuous variable, because since this is a icon of, sorry, this is the icon of scale. So here you will enter the continuous variable and here you will enter the categorical variable. So you enter age here and then you enter in this case. So what is the odds ratio? Right now you have not gotten the odds ratio. So if you come to this option of there, can you see that I am not checking these things now. First you go to this model coefficient. And if you see this model coefficient and click this odds ratio, and then you can see the p-value of odds ratio. So what is the odds ratio of this? This is 1.04 along with its confidence interval. And what is the p-value? It is 0.0 less than 0.001. So this odds ratio or its significance in only one as a one variable, this is a unadjusted odds or adjusted odds. All of you please write in the chat box. Priya, Anjana, Shruti, Anju. So this is unadjusted odds. True. And that's how I said that this is important, because here you can get the adjusted odds of a unadjusted odds of a continuous variable also. So its p-value is less than what cutoff we have set? 0.2. So I'll take this variable. So one by one, you can have like again gender, and you can see its value. So the p-value here for gender, you will see it is 0.03. So again, it is significant. So I'll take this variable also into my analysis. So you keep on writing and entering the variable one by one. With race, you can see.
Madam, gender, race to be put in factors.
Oh, I'm sorry. Sorry. Yes, thank you. By more, that's why it has taken it as a continuous. Yes, even if you put that here, it will take as a continuous 0 and 1. So you can see here, although the p-value is the same, and the odds ratio is 1.95. Thank you. And then race in factors. And there you can see here, it gives you the levels. So black, white means it is giving the odds ratio in these both, at both places it is white. So it is the odds ratio in black taking the reference category of white. It is the odds ratio of others, and odds ratio of what? Odds ratio of death in others taking the reference as white. This is the odds ratio. Okay. So if you see the p-value, it is 0.8 and 0.6. So should you be taking this in your final model? Yes or no? No, because the cutoff which we have kept, that is up till 0.2. So then I will not take race as a final this thing. Then again, I'll enter CVD. And the p-value of CVD, you see that it is 0.3. So again, this is not. So you may again take a call not to have this MI order. So it is 0.04. So you will take this variable. So did you understand? With one by one this thing, you keep on checking and seeing the p-values. So this is now statistical significance. So how you have concluded those 10 variables? All of you please write in the chat box. Initial what variables to keep? How will you decide? Let me see the chat box. Based on cutoff. So based on cutoff is a statistical that you decide later on. Maybe initial, you decide on the clinical significance and the previous literature. Like you review literature. Whenever you do research, you review literature. You have seen in the previous literature that these variables were significant. So initially you take those variables which are there in the review of literature, and maybe which you think as a clinician, or you ask from, like we always ask from clinician, like which are the variables which out of experience you think that is very important for you. Then even if that statistical significance is not there, you take that this thing variable as a predictor variable in your model. Yes. So clinical significance first, good. Then unadjusted odds, yes. And even if the unadjusted odds is not significant, then like the p-value is, if it is 0.5, then also if the clinician is saying, you know, this variable is important for me, then you can write that in the justification that out of clinical significance, this statistical significance was not there, but still you have included that particular variable in that model. You can always write that. There's no problem. So that is there with the what variables to take. So right now, I will now have, since I have seen that those variables were not important, so I will not take race and CVD. Or you may take also maybe hemoglobin, I'll enter here. So Once you have entered everything, now there is something known as the model builder. So model builder, you've already entered those things in block 1. So I'm not telling you the options in the model builder right now, because in advance, we may tell you regarding the types of like backward, hierarchical, forward. So those options I'm not telling you now in the basic one. So we'll just go with this option, and we are not using any option in model builder. In the reference level, you can see that this is giving these reference level. So this is like reference is alive, male, first. You can again change these. If you want like female, you can change this reference level. So this option is not there in the 2x2 odds. So that's why that 2x2 odds you are not going to use, because you have got an option of odds in Jamovi, where you can change the reference level directly here, and you can also see what reference it is talking of. So again, I will keep the male as such. This is just to check that. Coming to the assumption check, it is the collinearity statistics. So collinearity statistics, we talked about the assumption of collinearity. So if you click that, you will see that it gives you the value of, and there is a VIF and tolerance value. So VIF is what? Variation inflation factor. So the value of VIF should be less than 10. If it is less than 10, that means it is acceptable. So all the values of VIF are less than 10. That means that there is assumption of collinearity is met. Now you come to this odds ratio you have seen. And then coming to the prediction. So here you can see the cutoff. It has automatically took the cutoff of 0.5. So you can change the cutoff, but there's no need to do that. So that and this we are not talking right now. So this is the overall, and if you see the overall model fit, then in overall model fit, you can again click on this Cox and Snellen square, and then click on the overall model test also. So if you click on this overall model test, you will see that this p-value is significant. So then you can see that this p-value is significant, and this is the R square, the McFadden. There are 3 types of R square. You can, and what do we mean? We can say that 18% or 15% of the variation in the death of the individual is explained by these variables which I have taken. This is the meaning of the R square. And these are the 2 other fit measure, that is the deviance and the Akaike inflation AIC. But again, most of the time we use the overall model fit and the R square statistics. So Priya is writing, please repeat this step. So this is the collinearity statistics. I will again uncheck this. You click on this assumption check, and that is a collinearity statistics. If you click this collinearity statistics, you will get this value of VIF and tolerance. So this VIF and tolerance is opposite to each other. Now focus only to VIF. The full form of VIF is the variation inflation factor, and then variance inflation factor. And if the value is less than 10, that means variables are not collinearly related to each other. So this was met. Okay. That's why we say that this assumption is met. And this is how now coming to writing the interpretation. So in this table, this odds ratio which you have, that is the adjusted odds. So you will have a more column here, that is your unadjusted odds. Okay, so Ria is giving so that YVF should be low. Okay. So that's the explanation of that it should be less than 10. And you can see here the significance. So you will find that this is significant, age is significant, gender is significant. So MI order, remember MI order was significant initially, but it is not significant now. So this is the, if you see this is not significant, again this type is not significant. This category is also not, again you can see smoking is significant. This is also not significant. So that happens. That's why you should take both adjusted and unadjusted odds. And you can have a write-up. So how to explain this odds ratio? We were doing in the odds ratio session also. You can either explain it in the form of a ratio or you can explain it in the form of a percentage. So like for gender, if the odds ratio is 3.45, what will I say? And you can see it is the odds in female, reference categories male. So I will write that the odds of death in female was 3.45 times more than male, or in form of percentage, you do 3.45 minus 1. So you can write 245%. So the odds of death were 245, like 245% more in female as compared to male. So this is how you can express it in the form of percentage as well as a ratio. For continuous variable, how do you explain? So if it is 0.105, you say, yes, Khushbu, I'm please repeating. Vikram, 240, that's how we call it. Generally, percentages we express when the value of odds ratio is less than 1, then it is more meaningful. Otherwise, saying that 245% more, it is a little like not very much clear to the reader. That's why we say odds. So this was regarding the categorical. I will again repeat it. Yes, Kaushik is writing, increase of 1 year of age will lead to 1.05 higher odds of death. True. But now one more question. If I increase 2 years of age, then how much odds will be higher? Yes, Dr. Kaushik, this question is to you. So if I say that increase of 2 years, then what will be the odds? So it will be like, it will be like 1 into 0.5 into 1 into 0.5. Similarly, if it is 3 years, then you will multiply this 1.05 into 1.05 into 1.05. You will not do 3 into 1.05. Okay? It is like that. So 1 year is okay, but for 2-3 years, yes, Ria is writing exponential increase in odds. So like for 2 years, you will do 1.05 and then 2 exponent. So that's the exponential increase of odds. Regarding the percentages, again with some other example I may express. Like in this case, you can see that the odds in smoker, it is 2.06 times. So I can say that odds of death in smoker was 2.06 times as compared to the odds in non-smoker. Or if I want to express it in percentages, what I'll do? Yes, 2.06 minus 1. That will be 1.06. You have to multiply that with 100. Then you will say that the death in smoker was 106% more as compared to the non-smoker. Okay, Sheetal? So coming to the interpretation and table. So maybe this is the, this you can see we have left the this thing column here, but you have to fill it. You don't think that this will be blank. We have only written the adjusted OR. So you have got this table where you will write the value of B, significance level, crude odds ratio, adjusted odds ratio, and then you do the write-up. Okay. So one of you can read this for me. Maybe Sheetal can do that because I can see her now. Her or him, I don't know.
Yes, ma'am.
Okay, her, I'm right.
So a binomial logistic regression was performed to ascertain the effects of age, gender, race, CVD status, MI order, MI type, BMI category, smoking habit, and baseline hemoglobin level on the likelihood of death at last follow-up. So the linearity assumption was tested using model fit and pseudo R-squared statistics. There was one standardized residual with a value of 3.099 standard deviation, which was kept in the analysis.
Let me delete this because this you don't get here. That was from the SPSS actually.
Okay. So the logistic regression model was statistically significant with chi-square value of 36.16 and p-value less than 0.005. And the model explains 23% of the variance in death and correctly classified 72% of cases. Out of the 9 predicted variables, only 3 were statistically significant. Those are the age, gender, and smoking status. The females had 3.2 times higher odds of death than males. Increasing age was associated with an increased likelihood of death. Similarly, the smoker has 2.09 times higher odds of death with respect to the non-smoker.
So this is how you write the interpretation. So if it is okay and if you have understood, I'll again explain the commands before you go to the breakout room. So how you do it? Maybe I'll move everything back. So first you do the unadjusted. So you check with 1 by 1. Age here, you enter the value, see the value. Again, do it with gender. There are 2 boxes. The mistake which I did, please do not do that. So enter the variable in the appropriate box. So Anjana is writing, do we have to interpret the results for both adjusted? Yes, we have to, because then only you will say that it was in the unadjusted, it was not significant, but it became significant in the adjusted. Or in unadjusted, it was significant, but in but in adjusted, it was not. So it is an important discussion point in your write-up. Those variables who have changed their category. No, you have to do both, Anjana. Both. Like here we have only kept the significant one, but you need to do the detailed write-up. Those who were not adjusted, like the unadjusted odds, it has gone down, or maybe the p-value, initially it was significant, but now it is not. So you need to mention that also. So first you do the 1 by 1 this thing, and then what you do, those variables which you think that they are important, you like cutoff, you take 0.2, enter those variables. Maybe I just, for example, I am entering the age, gender, BMI order type, maybe the BMI category, smoking here. Then come to this reference. I'm not doing anything with the reference level. I have just told you in the assumptions check, you can click this collinearity. Then you will see that collinearity statistics, it will appear. No, it is why it is opening this. Let me. Yes, so collinearity statistics, if you click this, you can see this VIF and tolerance value that will appear. The value of VIF should be less than. So chi-square is Where is the chi-square? Oh, by mistake, that was on. That's why it came. Where is the chi-square? Okay, 72% accuracy. That is actually the null model, which we see in the... okay. Actually, this overall model coefficient, this is the chi-square value. That was some other... This, can you see this chi-square? That was by mistake. It was this thing. This is chi-square, 37.2. Okay, Anju. This is there. And that 72% write-up which you saw, that is in the value of null model, when you don't take anything. So that you have like... just a sec. How to remove this?
Madam, you can click on the sound button, I think.
Okay, that's why I was thinking. No, but this is audio switch.
Okay.
Let me do that. No, it is not happening. Audio switch. No, it is not this evening. Let me do. Wait.
Ma'am, a button next to the purple one.
8 minutes.
Maybe.
Yeah, I'm also trying. What happened? Okay, this one. Yes, thank you. Oh, again it. No, but again it. Yes. Thank you. So I was talking again. This descriptive has come. Yes. So that was 72% was the null model actually. I was expecting this question because 72%, like when you don't do any modeling, in that case, what you do, that comes from the contingency table. Actually, that SPSS gives you the null model. But here in Jamovi, if you do like gender, when you don't have any prediction, then what is the percentage accuracy? So that null model, Jamovi doesn't tell you the null model actually. It only gives the overall model. That was since we have included that from the write-up. So if you see the descriptive of FSTAT, so you have to go to the descriptive and enter the FSTAT and make a frequency table. So you will see that 63.7% are alive and 36.3% was dead. So I should have written there that 63.7. So the null model is predicting if I am saying everyone is alive, then how much I am correct? What is the probability of my being correct? It is 63.7%. So that we understand by the null model, which Vikram was asking. And then when all the model variable which you take into the account, like this one, this is the full model. So that is the difference between a null model and a full model. So actually SPSS starts from a null model and then it keeps on making the those many model. That model building part we have not touched upon right now, because to keep things simple, we have only restricted ourselves in the basic logistic. There are many advanced logistic commands and options, which we will do once you are there with us in the advanced logistic, where we'll tell you only logistic for 3 days. Okay. So if it is okay, Again, I think I need to tell you few more commands. So you go to this model foot, you click on this overall model test. If it is significant, then you say that your variables which you have made and that R square that is significant. In the model coefficient, this odds ratio is not clicked. So you need to click it, and the confidence interval also. And this prediction, you will see that cutoff. Again, you have these options of ROC here also, but I'm not telling you those as thing right now. And then in the save option, if you want to have a column of those predicted values and residuals, you can click that. So if you click that predicted value and residual, you can see in your data set that there will be appearance of another variable here. Okay, it is not happening, maybe. So that is not, in the SPSS, it used to have that. Okay, so this is in the data. Yes, now it was taking some time actually. Just a sec, it is taking. So you can see here that residual, but where is the predictor? Let me check whether I have clicked that or not. So you can go here. At times this Jamovi also behaves like you can go to this data. Yes. So now you can see these are the predicted probability which we have shown. And this residual is the difference between the observed and predicted. So predicted is 0.74, 0.3. And then this is the actual status. And if you like click on this Cook's distance, I've not told you. This is again to see whether any outlier is there or not. But you can skip this also. So in this basic one, you only restrict yourself with this interpretation of odds ratio, p-value, unadjusted odds, adjusted odds, overall model coefficient, and how to decide which variable to keep. Okay.
Ma'am, here the adjusted odds ratio p-value that needs to be less than 0.2 or 0.0?
No, it should be less than 0.05. Only for initial decision whether you will keep those variables in your model or not, that p-value we keep up till 0.2. Here though, it's like other usual p-value which is less than 0.05.
Ma'am, also in model fit, can you please tell again the interpretation of the pseudo R square?
This one. So model fit is like you get R square. It is my mistake. Like initially Anju also pointed out, I should have covered correlation first. But since it was a small topic, I thought maybe you people will be burdened if I cover this logistic later part. R square is basically known as the coefficient of determination. So that value of R square, it is the correlation R square. If you multiply that by 100, it tells you the percentage variation in the dependent variable, which is due to the independent variable. So like you can say there are two types of R square here, McFadden and Cox and Snellen. So both have got like this Cox and Snellen is 17.5%. So you can report one, like you can say that 17.5% variation in the status at the time of discharge, which was death, that is due to these variables which I have taken in the model, like age, gender, MI order, BMI cat, and smoking. Okay, and there are ways to increase this R square. If you like remove one variable, then R square will be increased. So right now, what is the R square? It is 17.5. So if you take like this MI order, this is not significant, this BMI cat. So if you like remove this, then you will see again not much. So value of R square is still 15% only. So by